triangle, and you have to know which one it is.
In what case would I use tangent?
Opposite and adjacent.
Okay.
So this A in the formula, or big A, stands for adjacent, O stands for opposite, H stands for hypotenuse.
Okay. So if 17 happened to be like the adjacent and 13 was the opposite, then I would use tangent to
That's
find
right.
B.
That's right.
Okay.
Is that okay? Clear?
Yes,
Kind of?
that makes
Okay.
sense.
All right. So the setup here is the sine of the angle, which we don't, I'm sorry, the cosine of the angle B, which we don't know, okay, equals the ratio of the sides. So in this case, it's 13 over 17.
Mhm.
Okay. This is not the answer on the right. The answer is we want B. B is the angle. Do you remember from class how to undo cosine?
Not quite.
Okay, so I will show you this step here. You take what's called the inverse cosine of both sides,
Oh, yes, the arc. Yeah, I
or
got
the
it.
arc cosine.
Mhm.
Now, I'm showing this step. What most students do, though, and this is fine, is they just write B equals cosine inverse or arc cosine of 13 over 17, like that. All right. Now, I did ask if you have a calculator today. You want to make sure your mode is in degrees. If you have a question on that, I can help you resolve that. Do you want to try calculating this for us, please?
Yes, okay. It says around 40.12 is what it says.
Yes, very good. Okay, so I agree. It's 40 point, we'll just say 1 degrees. Degree symbol is important there. So you're asking me a question here. This is very important here. Let's say I give you another right triangle, and I tell you that this is 12 and this is 8, and I want A. Which question here is which trig function are you using? Are you using sine, cosine, or tangent? Tangent. So the tangent of A equals what over what in this case?
The tangent of A would be 8 over 12.
8 over 12, good. And then the actual value of A is the arctangent of 8 over 12. Can you give me that value, please?
Mhm.
Round to 1 decimal place for me.
$33.7.
33.7 degrees. So that's A. Let's say I wanted you to find B. What would you do to find B in this case?
I would probably do sine 33.7 over 8 is equal to whatever sine B is over 12. And then I would,
So it sounds like you're trying to use law of sines.
yes.
Okay, that's too much here because you have 2 of the 3 angles.
Okay, yeah. So
You
then
just have to
first you just have to do that. Okay, I didn't see that.
Yeah,
yet.
I wasn't sure if you're going to tell me tangent or something else. That's it. And sometimes we get so involved in these calculations we forget, like, oh, I can just subtract from 180.
Yeah.
90. It's like, yeah, just do the easy one because you don't get any points for doing it the hard way.
Mhm.
All right, let's look at number 2 now. Again, we can go in any order you want. I'm just going in order until you tell me otherwise. And I
Okay.
like that you're asking a lot of questions. You should always stop me if something's unclear. Hey, Matthew, I didn't understand that. You went too fast. You're not going to offend me. My goal is to help you
Mhm.
work through this. Okay, what is the length of PR? Basically, we're trying to find the hypotenuse here.
Mhm.
And we're given this right here in degrees, minutes, and seconds. Now, this isn't really used as far as I know, but we do have to know how to convert between them. So the short The short of it is it's 28 plus 19 over 60. So minutes are always divided by 60, plus seconds are divided by 60 squared.
Okay.
Okay. And there's actually kind of a nice progression here where it's 61, 60 squared. I don't know if this rounds nicely, but are you comfortable putting that into your calculator to get
Yes.
an answer for me? There is a way in your calculator to actually have it convert, but what if you don't remember on the test? It might not be good strategy here. Give
Okay.
it this to me to 4 decimal places, please.
Okay.
How are you doing on this?
Okay. It says 28. You said 4 decimal places?
Yes, yes.
28.3308.
Very good. Okay. Now sometimes it's good to redraw the picture just because in my case, I write big. I got a lot of things going on here with
Yeah, she makes us do that anyway on our homework, so just
okay.
for
So you're
practice.
familiar with that then. All right. Now, relative to the angle now that you know, what is 18 and what is C? And again, the answers are adjacent, opposite, or hypotenuse when you're trying to figure that out. Relative to this angle, what's 18? What's C?
Okay, so 18 is adjacent and C is the hypotenuse.
Okay, so which trig function are we using? Sine, cosine, or tangent?
Cosine.
So the cosine of that 28.3308 equals what over what in this case?
That would be let me see. Okay, that would be 18 over what? 18 over C.
Good. All right. Now, this is different than the last ones. We're solving for C. The cosine of this is a number, meaning it's like we can put in our calculator and get something there. But how do you get the variable out of the denominator? That's our focus should be on the side with the variable. What do we do to undo, get the C out of
Okay.
the bottom? Do you remember?
So yeah, so you just multiply C on both sides and
Okay,
then would do that, and then you would divide the cosine
that's right.
28. So then it would be C equals 18 over cosine 28.3308.
Notice that they effectively swap positions.
Mm-hmm.
That might be a shortcut for you. So you go right to your calculator for this. Go ahead and let me know what you come up with for that.
$20.4.
Yes. Okay, and if there were units, this one doesn't have any. Oh, it does centimeters. You would want to include that in your answer.
Okay.
Any questions on that before we move on to
No, that makes
algebra?
sense.
Okay.
Yes.
All right. So the nice thing about number 3 is that there's a picture that's given. One of the things you should always recognize that because you're doing right triangles, you're going to have a right triangle to work with. Okay.
Mhm.
For now, though, could you convert this degrees, minutes, seconds out to like 4 decimal places for us, like we did in the last problem?
Yes, okay. Let me write that up. Okay, I got 37.020728.
Okay, I agree. Now the question is where is that in this picture? Is it A? Is it B? Is it something else? It is the angle of elevation. Do you remember that from class? What that
Mhm.
is, where that is
So
here?
that would be A.
It is A. So the angle of elevation is always looking up. The depression angle is the one that's made with the horizontal at the top here,
Mhm.
which is the same as the elevation here down here at the bottom. All
So
right.
it's they're equal, yeah,
Yeah.
because of the.
You know, why do they give them different names? I don't know. They are equal. I mean, it took me a while, you know, when I was taking this class to realize that. And so I always tell students that because like we shouldn't leave this as a mystery. it's
Mhm.
it's not a big deal. This is 600. Now the question is, are we finding A or C in this problem? Based on what you see here, what are we finding?
We are finding C.
Okay, C is the distance from point A to the top of the tower.
Mhm.
That's C, but we're also finding the distance from the height of the tower. So we're actually
Yeah,
finding
so
both in this
both.
case. Yeah, it's kind of a trick question there. All right, so your choice, right? You have to decide which one you want to find first. You know, what do you see? Do you want to find A first? Do you want to find C first? It really doesn't matter. Which one is more appealing to you?
Um, let's just do A first.
All right, so A relative to this angle is the opposite. This is the adjacent. Which trig function is that?
Opposite adjacent, that's cosine or tan. That's
Tangent. Tangent is A over 600.
what was that? Kind of, it wasn't like an acronym, but it was kind of a thing that you said in the beginning. I think that would
Well,
help.
this is how a lot of people remember it. So Katoa, there's some words that go along with this if you want. I'm not big on like helping you how to remember things because the brain works differently for everyone, like how you remember stuff.
Mhm.
Some people just see it and they remember it forever. Some need a song, some need note cards, Quizlets, you
I
know.
think that will help because that's like always something that I like can't remember. So that will help definitely.
Yes,
Okay.
and so the way I write it though is I write it as the fraction so that I know where each one goes, you know, rather
Mhm.
than remembering O is top, I just write it that way because we know to read left to right and then top to bottom. That's kind of my way of
Yeah, it
thinking
just like
about
shows
this.
the dividing method also.
Yes,
Okay, so then the tangent of 37.0728 is A over 600.
yes. I'd like you to solve that for A for us, please.
Okay. So A is 453.33.
And what are the units of that?
They are meters.
Yes. Does your teacher typically tell you what to round to because this problem doesn't specify, or do you need?
Normally, so she might want it Yeah, so if it's just distance, then normally she says 2 decimal points, but sometimes it's 1. Normally she'll specify.
Okay.
Normally before the test she'll say, but and normally it ends up being 2 or 1.
Okay. So we'll just go 453.33 meters.
Mhm.
To find C, you have a couple of options here. Again, this is kind of like when I was asking you for that other angle. Use
Yeah,
the one, the path of least resistance. So in this case, you could use Pythagorean theorem. You could say, okay, it's a squared 600 squared plus b squared 453.33 squared equals c squared. That's totally allowed. If you like the trig function sine, cosine, tangent, you can use cosine of this angle equals 600 over c.
yeah,
Does
I think she gets mad when we do Pythagorean
Well,
theorem.
it's still valid.
So,
It's correct. It's totally
so I
correct.
think if I was gonna do it, I would do law of sines.
You would not use law of sines here.
Law of sines,
That's like going. What I meant is you're either using cosine or you're using
because you're
Pythag.
just starting off with what you have. You don't like use what you've
Well,
gotten.
let me try to clarify this here. So there are an infinite number of triangles
Mhm.
in math.
That's also something I did want to work on today, like looking for ambiguity as well.
Okay, we can get to that as well. There are right triangles and then there are non-right triangles.
Mhm.
So the Pythagorean theorem, the sine, cosine, and tangent stuff we've been doing are all for right triangles.
Mhm.
Non-right triangles are law of sines, law of cosines.
Okay.
Okay, so your thinking has to be in this, this direction. Like I don't know if you play sports or do anything outside the classroom, but we do this all the time in real life. It's like I'm over here, maybe a language class is like when you're dealing with right triangles, like these are the tools you can use. Non-right triangles, you use this. Now, law of sines does work for right triangles, but it's like using quadratic formula when you can factor. It's like totally unnecessary,
Okay.
like you don't churn out milk and butter in your your house. You just go to the fridge and get some milk and butter, hopefully. So hopefully that makes sense. In terms of like what we should do here, let's just use cosine. Cosine of 37.0728 equals adjacent 600 over C. And to solve for C, we talked about how these just swap positions. So
Mhm.
C equals 600 over the cosine of 37.0728.
Okay. Okay. So cosine 37.0728. Okay. 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 So
Let me know when you got that number.
752.0. So 752.
Okay. Meters, don't forget your units. All of a sudden they are important in this class.
I know.
Yeah.
Like this
Maybe,
off.
maybe at the top of your paper, write units, something like that. Great. So, I mean, it's consistent. It's the longest side is the hypotenuse,
Mhm.
numbers are reasonable. I mean, that's all you got. You could redo the calculations if you had time on the test, but
I probably won't. She doesn't really give us a lot of time, which is frustrating, but
yeah. All right, number 4 here. Um, look at this next here. So uh, this is one of those where you have to draw the picture, and that's really hard. Like that if you get the wrong
I hate
picture,
that.
you just
I
yeah.
know.
So I'll try and help here as best I can. Um, this right here, north 13 east. So you use the first letter, and that tells you kind of where you're going up in this case. Boy, that's drawn terribly. You're going up, but then east means you're going to the right here. So you're actually going 13 degrees there. Is that consistent with what you've seen in class?
Yes, okay.
Now you're going 8 hours at 11 kph, kilometers per hour. So you have to take 8 and multiply it by 11 to know how far you've gone, which is you've gone 88 kilometers.
Okay, that part always confuses me. I always forget to do that.
So
Okay.
it's distance equals rate times time. Are you driving currently?
I am, yes.
So that maybe intuitively, if you've gone on, anywhere longer, it's like if you drive at 60 miles per hour for an hour, you've gone 60 miles. You can think through that maybe a
Yeah.
little bit. The other ship travels in the direction south 39 degrees east. So you start going south, and
But
this
it's
this
also east, so
yes, it's a little more. I mean, you don't have to be that accurate, but you should be, somewhat accurate. And then it's 6 times 13, 78 kilometers.
okay. 78 kilometers. Okay.
So we're trying to find the distance between the two ships.
Okay.
And there's no reason to assume that this is a right triangle. There's no reason to assume that like this, they're underneath each other. That there's a transition here in
Mhm.
this problem for that.
Okay,
So
so what my question here is, can I use those two angles to find that one that's right in the middle, like 13 plus
yes,
39, so 180 minus whatever that is to find that middle
yes,
angle?
yes. And we need that angle. We absolutely
Okay.
need that. The reason we need that angle, I'm gonna just kind of redraw it not to scale here, is this is 88, this is 78, and we want the angle between it.
Okay, so if I put that into my calendar, then not my calendar, my calculator, it's 128.
128 degrees.
That's
Okay, so a real quick review of when you use law of cosines, because this is a law of cosines problems. There's two cases. Case one is when you're given a side angle side. So the angle has to be between the two sides, and that's used to find a side. Okay. In this case, it'd be the side across from it. The second case is when you're given all three sides,
Mhm.
and that's used to find an angle. Does that sound familiar?
Yes.
All right, great. So the problem with the law of cosines is there's these formulas, there's 3 formulas and there's 6 formulas, like it's too much, right? You should always consider the side or the angle you're finding to be C, either little c as the side, big C as the angle.
Mhm.
And you can start out remembering law of cosines as it is the Pythagorean theorem. Does this look like the Pythagorean theorem? A
Yeah.
squared plus b squared, c squared, good. And then from here, you have to remember it's -2, but then the two letters are A and B because they're on the same side here. Cosine. And so this matches. This letter, these always match here. Now, this may
Okay.
not be the way you're doing it in class.
It is. Yes, it
Okay.
is.
All right, good. Sometimes I, hear weird things. I try to make your life simple. I don't want you to overcomplicate this stuff because it's
Mhm.
hard enough as is. So A and B don't matter, like in terms of their order. Do you put A here and B here? Fine. Okay.
So if like I was solving for the cosine of B, it would just switch some of the letters around?
So like the way that I would show you this in the class is I would have you only use this one, and then we would reassign the letters to be consistent with this, meaning we're either finding big C, or I'm sorry, little c, the side C, or we're finding angle C. And what you said is like let's say there's a triangle where this is B and this is B. I would just cross those out and go back to what I'm used to, which
Mhm.
is this. I understand if you don't
She
like
also has
that, or
us like she has us use like alpha, beta, gamma too to like
right. And
differentiate
that's because
better because they look
this book,
similar, too.
yeah. I mean, those are nice, but most
I
students
get
aren't comfortable
confused
with Greek
sometimes.
letters. And however you do it, like the more math you take, the more options you get. And
Mhm.
that's what I want you to also hear here is that here in this discussion is that like you get a choice. Like ultimately they're grading you on showing the right equation and the answer and the work, but they actually don't care. You could make up your own symbols. You could use this symbol, you could use this symbol, but you should, pick something you like, something you think you could reuse on the test and be consistent with it. Okay. So the next step here is to start putting some numbers in. 70, I did it this way. So 88 squared plus 78 squared minus 2 times 88 times 78 cosine of 128 degrees.
Okay.
So this is c squared though. So once you get these numbers in, go to your calculator. You want to get this. You could take the square root right here and be done with the problem. Just if you don't do that, make sure you remember to take the square root here.
Yeah, that's important.
You should
Okay.
also look at the reasonableness of your answer. Like at worst, they're like 88 plus 78 apart. Like if one went straight up and one went straight down. So if you get an answer like 5,000, that's way too big. You gotta kind of know where you're, whether it's reasonable or not.
Yes. Okay. I'm gonna put this on to my calculator. There's like so much to like convert, so I'm gonna like do that.
And you're using a TI 8384.
Yeah, 83. Yes.
Okay.
I love
So
that.
I've got a virtual one. If you ever need me to show you any calculations, I can do that. Or if you have questions about how to enter this in the calculator, can also
Okay.
do that as needed.
Okay. I think I did something wrong. My calculator is not liking it. It's giving
Are you getting
before I square, it's giving me a negative answer.
okay? Yeah, that is a problem. So you're using a TI 83.
Yes.
You said okay. Give me just a moment here to pull this up, and see here. Tools. There it is. All right. All right, so this is my virtual TI 83. There it is. Okay. So here's the way I would have you enter this: 88 squared plus 78 squared minus 2 times 88. Now I showed it in parentheses, which also works. Like I can put in parentheses 78 here. It knows to multiply those.
Oh yeah, that's right.
Cosine of 128. Now I have to go check my mode before I go and do this. I have to go make a degree, but yours is priority set. So a few options, like we could do a whole lesson on just, I used caret in the first position. I use a square there. Like you have to decide like what you like when you're, just like when you use a phone, you figure out how you respond to
Okay.
people,
Minus 2 times 88 parentheses 78. Then cosine 128. And then let me check my mode also. Okay, how do you like make it say yes when I put it in degree mode?
You just hit enter. So if you go to mode, mode,
Yeah.
you just go over to it and hit enter, and that's it.
It doesn't like that. It's like not letting me leave it.
Oh, I'm sorry. You quit second. I understand what you're asking. You hit second and quit.
Okay. Cool. All right. So then enter, it says 22279.8.
Right. So here's a really neat feature of your calculator. Like we want to take the square root of that number. So we go and find the square root, right? There it is. And you're probably used to just retyping it, but if you hit second A and S, which is down here under the negative, A and S refers to your most recent answer. so you don't have to copy and paste
Just
that.
blew my mind.
Yeah. This calculator is really impressive when at the time when it was made. I mean, now it really pales in comparison to the things we expect, but there's actually a lot that it can do.
Yeah, it's pretty neat.
So
Okay.
that's a reasonable
That's,
answer, right?
and
One,
that's kilometers, right?
yeah, and that's what we, that first answer, 22,000 kilometers away. That's unreasonable. When you do
Yeah.
that, that's why I always tell students, like, please, like, just see if it's even reasonable. If you driven anywhere, you get a sense for, like, okay, this is 5 miles away, it's 20 miles away, things like that.
Mm-hmm.
Okay. Any questions on that before we move on to something else?
No, thank you.
All right. So here's what I want to do. I want to send you this thing called a trig cheat sheet that I really like, and you will maybe potentially need use in the future in this course. Drop that in the chat here. You may find that that's incredibly useful for going this part of the course and going forward.
Okay.
Do you want us to work on the unit circle there, which is on page 3 of this, or do
So
you want
I
us to do
feel
some?
like for me, I don't know how to like memorize it all completely because that's something that we have to do and something that's really important to
Ah,
know.
boy, that's tough.
So that's like
All right.
my
Let me
thing.
give you some guidance on that here. Um, so memorizing is not really a math skill. It's more of like,
Mhm.
are you a visual learner? Are you, I don't remember all the words, but it's like, are you hands-on? Are you visual? Are you auditory? All those things, right?
Probably like a mix of visual and auditory.
Okay. And like, that's the reason I ask, is because, like, I don't have the ability to say, like, this will always work for you if you do it this way. I can
Mhm.
show you the patterns that are here. Okay. Now you absolutely have to know quadrant 1. You,
Okay.
you just have to know it. Okay. So you have to sit there and say, like, let's just say your test was on Monday. You're like, I'm going to learn quadrant 1 today. And then tomorrow I'm going to learn the other 3 quadrants, or because the other 3 are based on quadrant 1. If you can get quadrant 1 down, you can do the rest, but you chunk it out, things like that. One of the things you should notice is that there's only, on the outside here, there's only 5 numbers that are answers: 0, square root of, sorry, I'm going to do this in the right order here. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Do you see that there are only 5 possibilities here?
Yes.
Okay, that's important for you to recognize. It's not like there's an infinite number of these. There's just 5. Okay.
Okay.
Now, how are you going to remember, these angles? So what some students do is they learn the degree ones and then they convert from degrees to radians. That's okay. It's not great. It does work. 6, 4, 3 don't really go together.
Hmm.
I'll just say that. Like, there's not like a great way to remember that. So I can't help a ton there. What I can do is show you that if we draw this triangle here, this one right here, and I'll redraw it over here, we know the hypotenuse is 1. Okay.
Hmm.
And if you go to the calculator, 1/2 is 0.5. This is 0.707, and this is 0.866. Okay.
Okay.
When you look at this side, vertical or horizontal, the horizontal here, you probably visually can see is closer to 1 than this one.
Yeah.
And that's how you can say, well, it's probably the square root of 3 over 2. The other one, if you draw it really nicely, you recognize it is about half the way up from there.
Okay.
Okay, so there's some things there you can do to sort of draw these triangles to get like a better sense of like what should it be if you don't know.
Yeah, I have like I have like a unit circle quiz on Monday that's like, what's the cosecant of this angle? What's the secant of this one? What's
Okay,
like that
so
kind of
to
thing.
do that involves absolutely knowing the first quadrant, and then there's like a little recipe that I can give you to help with that, but you have to know the first quadrant for
Mhm.
sure. So we could, for example, spend uh the last, so just to be clear, my lessons are 50 minutes, so we can spend the last 11 minutes working on that, and I can give you the first quadrant to kind of help. with that. That might be a good use of our time, not sure. But just this last point here is if when you look at this triangle here, you notice that the two sides are basically the same, not drawn as well. And that's why it's root 2 over root 2, root 2 over root 2.
Mhm.
So that's the kind of how you can remember the first quadrant if you're really like stuck on remembering the first quadrant. It's kind of like recognizing that square root of 3 over 2 is longer than 1/2. 1/2 is less than square root of 3 over 2 because that third triangle has a longer height, and you can see this goes about halfway down.
Okay,
Right.
okay, yeah,
Now a few other things here. Let me grab a blank unit circle. I know from what I understood from mom, she said that you just got a little bit behind here. It's like we can't cover everything today, but like hopefully you're getting a sense that if you like if we want to do just a lesson on the unit circle, like you could get it down in a lesson, so to speak.
okay.
But let me try to make one last point about the unit circle so you can see why you just need to know the first quadrant up here. Okay, so let's say you knew the first quadrant. You knew that this was square root of 3 over 2, comma 1/2, and I'm just talking about these x and y values, square root of 2 over 2, and then 1/2 square root of 3 over 2.
Mhm.
Let's just say you're right here. If you follow this all the way across right there, you get the negative square root of 3 over 2, negative 1/2.
Mhm.
And same thing for this other one, the one right above it. You get the negative square root of 2 over 2, negative square root of 2 over 2. How did I do that? Well, to get to this point in the first quadrant, you're going right and then up, which are both positive. To get to the third quadrant over here on the left, you're going down, left and then down, which is negative and negative.
Mhm.
So that's interesting. Like that's how you can quickly get the lengths or the numbers there, negative 1/2, negative square root of 3 over 2. Okay. So if you know the first quadrant, you can find the third quadrant.
Okay,
Now this angle right here is 30 degrees. The one that it corresponds to is 210 degrees over here.
180.
Right. So it's okay. If I know this one, I know that one. This one is 45. So that's 225. It works similarly with radian. Pi over 6 plus pi ends up being 7 pi over 6.
Mhm.
So now what most students do is they memorize these, but you actually can calculate them at every position.
Yeah,
Okay. And then so we can similarly do something to learn quadrant 2 and quadrant 4. But once you know quadrant 2, you do the same mapping for quadrant 4.
mhm.
So if I were teaching this in the classroom, I would make everyone learn quadrant 1, give you a quiz the next day in quadrant 1 only. Then we'd go to quadrant 2 next day. Then I'd make you learn quadrant 3. Then I'd make you learn quadrant 2 to find quadrant 4. So
Mhm.
that's how you learn it if you want to actually, get it down.
Okay, yeah, I'll do that for sure. Thank you.
Okay, now let's go back to uh, you know, unit circle stuff, which is, and we'll start really easy here. X refers to cosine, Y refers to sine. Okay. So if I ask you the cosine of pi over 3, that's the X value at pi over 3.
Okay,
What would that be in this case?
okay, so the cosine of pi over 3.
Yes, the X value at pi over 3, because X is really cosine.
Okay, let's see.
I think you're over.
Okay.
I'm guessing there's a gap here or
It's
something like
just, it's just 1/2.
1/2.
Okay.
Do you see that it's just the x value of the ordered pair there?
Okay, yeah,
That's
okay.
all. That's what I meant by this. X is cosine, y is sine. So if I ask you the sine of pi over 4, I'm literally asking for you to tell me the y value.
Okay, so it's negative, or so it's just positive square root of 2/2.
Yes. Okay. Now, because like consider that I'm giving you the unit circle and I'm asking the first quadrant, like I got to make these just a tiny bit more difficult here. What is the tangent now of pi over 3? And you have to remember that tangent is really sine pi over 3 over cosine pi over 3. Is that familiar?
Yes, okay.
Okay. And so when I ask you about tangent, I'm really asking about sine and cosine. I'm really asking you for the y value at pi over 3 over the x value at pi over 3.
Okay.
What's the
So
y value there?
so the tangent of pi over 3 would be square root of 3/2 over 1/2.
Okay, good. And this is correct, but not simplified.
Mhm.
So do you remember how to get rid of a fraction inside a fraction here?
Not quite.
Okay, so there's two options. One is to recognize that since the bottoms are the same, they just cancel.
Mhm.
And that's the kind of the
So then
advanced.
it'd just be square root of 3.
Yes. But if you didn't like that, if you're like, I don't know if I remember that, what if they're different? That's a fair question. You multiply by the reciprocal. And on the bottom, everything cancels. On the top, you get 2 square root of 3 over 2. The 2's cancel, and you just get the square root of 3.
Okay.
Okay. All right. So the other type of problem you might see here, which is more difficult, is the tangent of 30 degrees. So this is
Mhm.
sine of 30 over cosine of 30. You might think, well, what's the big deal here? We just did that. It's y over x. Yeah, it's 1/2 over square root of 3 over 2, which is the 2's cancel. So it's 1 over the square root of 3. But this is not okay. You cannot leave your answer like this.
Okay.
And do you remember what you have to do here when you get something like this?
You have to um like you have to, what's it called? You multiply it by square root of 3. Yeah.
Yeah, it's called rationalizing.
Rationalizing. Yes, that's what it is.
Yes, rationalizing the denominator. You don't have to know that. You just need to know what to do. So
But
on the
if
bottom,
there's a square root in the numerator, then that doesn't matter.
that's
It's
right.
just it's in the denominator.
Isn't that interesting? Like, why does it matter when it's in the bottom but not the top?
Mhm.
I don't have the answer to that, but that's what they want you to do it this way. All right, so you get the square root of 3 over 3, like that.
Okay.
Is that okay?
Yes.
All right, so that's kind of the nice vanilla, plain problems here that you might see. Where we're going with this, and this is what you mentioned, we don't have enough time to get to all this, but it would be like a problem like what is the tangent of 225 degrees? Okay. Now, if you had your unit circle, okay, if you had your unit circle completely filled out, you could go to the tangent 225 degrees, which is probably why your teacher wants you to know your unit circle. Okay. So what I mean
Mhm.
by that is, let me go grab it. And it is on page 3 of that link I sent you in the chat there. Let me get rid of this. If you know this and it's perfectly laid out, you just go right to 225 degrees, y over x minus square root of 2 over 2 over minus square root of 2 over 2. You get 1.
Mhm.
Okay. But my thought here, like the thing I guess I would close out with is like, if you don't want to memorize this, like maybe you do for your unit circle quiz, but beyond that, like maybe you don't want to memorize it, there is a way to do this where you don't need the entire unit circle. This ends up being the tangent of 45 degrees by some things that I can show you at another time here.
Okay.
All right.
Yeah.
So normally I stop a little, just the lessons are 50 minutes. I'm gonna go ahead and stop here. Just